when you want to add or subtract two radicals, not only does the number inside the radical have to be the same, but the index also has to be the same. For example, if I've got 2 cube root of 7 and 4 cube root of 7, the numbers inside the radicals are the same, and the indexes are the same, which means that I could add those two radicals together, the cube root 7 and cube root 7. However, if I have cube root of 7 and cube root of 5, those are not the same, and I would not be able to add those two radicals together. So I need to make sure I have the same index and the same number inside in order to add those or subtract. So this example we have here, none of the numbers inside are the same, which means in this stage, I cannot combine that together. But what I can do is I can work with the numbers inside the radicals to turn them into perfect squares to where I could take the square root of them. So the first one that I have here for this, I want to rewrite the 50 as a product of two numbers for which one of them happens to be a perfect square. Now I could take 5 times 10, but none of those are perfect squares. However, if I do 25 times 2, then that would work because square root of 25 is 5, and 25 would be the largest perfect square I could find with 50. So that's kind of the idea. You want to think about what's the largest perfect square that would divide evenly into that number. Okay, so what would happen in the next step, I'll just go ahead and work this one out for you now before we do the other ones. You can break this up by using the product property. And so now that we have these broken up like that, the square root of 25 is going to be 5, and then I have square root of 2. So now I've actually taken that radical and I've changed it into one where there's a radical 2 here instead. Now, I wouldn't be able to do any more with radical 2. That would be simplified as much as possible. I'm going to do that for the other ones and see if I could end up with some radicals I could add together. All right, so I have 2, and then the 8 can be written as 4 times 2, and square root of 4 would be 2, so I could break this up into this, and then it would just be 2 times 2 times radical 2, and that one will be broken down as much as possible. For this next one here, I have a 12. Now 12, I could do 2 times 6, but none of those are perfect squares, but I could do 4 times 3. So I'll do 4 times 3, then I can do 5 times square root of 4 times square root of 3, and then I can do 5 times 2 times radical 3 because square root of 4 would turn into a 2. I'm just going to multiply these numbers out in front of each one. So I have a 30 square root of 2 minus a 4 square root of 2 plus a 10 square root of 3. Now the first two would be considered like terms because they have a square root in them. I have a square root here also, but that number is a 3, and that square root of 3 cannot combine with anything else that I have there. So all I can do is just take 30 minus 4 and get 26, and then we just put the square root of 2 on that. And we have plus square root of 10, square root of 3. Now these are ones where you wouldn't be able to add those together anymore because the numbers inside the radicals are not the same.